Do you know what's crazy about space travel? In the next 10 to 20 years, humanity could not only establish a permanent base on the moon, but also take the first steps toward a permanent settlement on Mars. Driven by SpaceX's Starship, NASA's Artemis program, and groundbreaking technologies that make us independent from Earth, let's break down this master plan step by step, from the near-term milestones to the visionary goals that will make us a multiplanetary species. I'm Sarwan and this is Mars Chronicles. Let's take off. Let's start with the moon, because it's the stepping stone to Mars. A testing ground for technologies we need to go further. Because on the moon, we're only a few days away from Earth. On Mars, we're at least 6 months away at best. So it definitely makes sense to test the technologies in our neighborhood first before we take the bigger step. NASA's Artemis program is the core, Artemis 2. The first planned crewed lunar flyby since Apollo is expected to launch between February and April 2026, with 4 astronauts aboard the Orion capsule to test systems. After that, Artemis 3 will follow in September 2026. At least that's the plan. The first landing at the South Pole, where water ice deposits are crucial for fuel and life. SpaceX's human landing system, based on Starship, brings the crew down. Initial tests, orbital refueling, and ship-catching attempts are scheduled for next year, so 2026. The uncrewed landing demo as well. Maybe you heard about it, but there was a bit of drama involving the interim NASA administrator Sean Duffy and the renominated NASA administrator Jared Isaacman. Duffy had lobbied against Starship along with other former NASA leaders. And Elon was really angry, so angry that he posted that enough is enough. SpaceX would dive headfirst into the moon ambition. So not just as in the Artemis program, a landing every 2 years or even less often, but in true SpaceX fashion. A shuttle service that makes everything else redundant. Starting in 2028, SpaceX will officially offer commercial flights to the moon, and starting in 2030 to Mars. SpaceX will now fully serve both destinations in their operations. It might seem like an impulsive reaction right now, but there's a lot more behind it. Elon also posted that the permanently shadowed craters at the moon's south pole are perfect for quantum computing centers. It would also be much more efficient to produce the fuel for Mars missions on the moon and store it in tank depots in cislunar space. Something that's expected to happen in 2026 is something that many people still can't believe. SpaceX actually wants to send the first ships to the Red Planet at the end of the year, regardless of the maturity of the Starship development. The goal isn't a smooth transfer, landing, and building a base, but rather to expose all the technologies to real conditions at their current stage of development. Exactly as they've done so far, depending on development by November 26th. Once it's running, they'll send between 2 and 6 ships with some cargo to Mars. The cargo will mainly consist of inexpensive raw materials, Tesla's Cybertrucks, and Optimus robots, because these will be needed in large quantities on Mars, and it wouldn't be a big deal if they were lost during a failed landing. SpaceX recently purchased 1,000 Cybertrucks from Tesla and had them delivered to Starbase. Now there are a lot of Cybertrucks around, and many employees are driving them around, but something tells me that they're going to load a few of them onto the first ships heading to Mars. You're probably wondering now why SpaceX wants to send ships to Mars with such brute force. If they're actually so sure that the landing won't work out. In fact, they're so sure the landing won't succeed that the first ships won't even be equipped with landing legs. If they reach Mars's surface, the engine compartment's outer shell will be left out. But why? Well, because the Mars transfer window only opens every 26 months. And if you miss that, the next opportunity won't come for more than 2 years. SpaceX prefers to test the hardware in the real environment. That achieves the best and most sustainable results. If something works or doesn't work in the simulation, that doesn't mean it will be exactly the same in reality. But if something works or doesn't work in reality, then you know it for sure. By 2028, Artemis 4 will build the Gateway space station in lunar orbit, a hub for long-term missions. At least that's the plan. Because you can't forget the usual delays. Gateway is a space station that is completely unnecessary. I'm not the only one who thinks so. I made a separate video about it, which is of course linked below. But what's important to know is that the station is only being built to scratch the backs of industry and international partners. The ambitions for the moon are not only achievable without a space station in lunar orbit, but also cheaper and more efficient. The argument that Orion needs Gateway because the European service module isn't powerful enough, because Orion and the European service module were deliberately designed to be weak, so that Gateway would have a reason to exist. Ideally, we use what has already been built or is currently being built. The Space Launch System rockets, Orion capsules, and service modules being built for the initial missions, because they are already paid for. For the time after that, we are relying 100% on hardware from private industry and Gateway. To keep the partners, who are us Europeans, happy, these modules can be used, at least according to the repeatedly nominated NASA administrator Jared Isaacman, to develop a nuclear electric propulsion system for interplanetary travel. Because NASA and ESA shouldn't be building hardware that industry can build for a fraction of the cost. Instead, they should be tackling the virtually impossible. That's what these institutions excel at. If they don't have to pour $7 or $8 billion a year into operating a single rocket that at best launches once every 2 years, then they can invest that money in developing cutting-edge propulsion systems. So let's now take a look at what the very concrete next steps are. So you could say that Gateway is not only unnecessary, but actually actively counterproductive. Because this station ties up valuable resources and means that the entire remaining architecture of the Artemis program has to be adjusted to include it. If a space station in lunar orbit ever becomes necessary, SpaceX will solve it with a Starship, which would be a much more efficient and cost-effective alternative. But what is the current state of technical progress? For example, using local resources on site has this system in place that is called In-Situ resource utilization. Devices like the advanced version of Mars Oxygen In-Situ Resource Utilization Experiment 2.0 produce oxygen directly from lunar regolith, which is the loose rock material on the surface. For radiation protection, we rely on natural lava tubes, which serve as underground habitats and protect the crew from cosmic radiation. In addition, robotics from companies like Intuitive Machines is used for prospecting, meaning the exploration and mapping of resources such as water ice. By 2030, a permanent base with more than 10 astronauts will be established, equipped with solar panels that provide 100 kilowatts of energy and the first commercial modules from companies like Axiom or Weist. This lays the foundation for a lunar economy that produces fuel for Mars missions and makes us more independent from Earth. But the moon is just the beginning. The real master plan revolves around Mars. I guess that's what everyone calls the master plan. Here, SpaceX is clearly taking the lead. Elon Musk presented his updated architecture in May 2025. The first unmanned starships will launch in 2026 during the next transfer window to test landings, unload payloads, and collect valuable data. These vehicles land with high precision, collect soil samples, and demonstrate the use of local resources on site. For example, the Sabatier reaction, which converts carbon dioxide and hydrogen into methane and oxygen, enough to enable return flights. I worked with INEOS to calculate exactly how much mass needs to leave Earth and how much needs to be sent to Mars so that the first return flight with a Starship is possible. So basically the question is, how much needs to be missed? The video is of course linked below. By 2028, the first operational unmanned missions will follow, with many solar panels, basic infrastructure, Optimus crews, and dozens of Cybertrucks. Also on board will be many tools, raw materials, various 3D printers, and food supplies, all stored in preparation for the first human crews on the Red Planet. In the best case, during the next transfer window, there will be extra cargo flights to Mars. Only after 2 expeditions have successfully entered and landed in the Martian atmosphere will crews be sent. If something goes wrong on one of these missions, it usually means the mission will be repeated as many times as necessary until everything goes smoothly. If everything goes optimally, the first crews will set off in 2033 at the earliest. Each of these manned ships will consist of 4 to 10 people who will build habitats, set up greenhouses for hydroponics, and assist robots like Optimus. Depending on the development status at that time, we're talking about 2 to 10 manned ships. Each manned ship will also be accompanied by a small fleet of its own cargo ships. Of course, most of this work will already have been done by the robots. It's not unlikely that the first crews will already have pre-grown vegetables. After 3 transfer windows, by then SpaceX will have sent hundreds of such humanoid robots to Mars. Technologically, Starship V3 with improved Raptor engines is aiming for a payload capacity of 200 tons complemented by orbital refueling with depot ships, up to 10 or 11 tankers per flight. The life support systems include closed-loop water recycling with 95% efficiency, carbon monoxide, 2 filters and radiation protection provided by underground habitats or walls made of water. The second crewed crossing will double the number of colonists. Those of the first colonists who want to return to Earth will then board the fully fueled starships and begin their journey home. After 2030, things will escalate. Annual fleets of more than 100 starships bring thousands of settlers to Mars, building cities with 3D printed habitats made from local regolith. Everything controlled by efficiency and complemented by biospheres that enable sustainable agriculture, such as potatoes or algae as a protein source. Imagine those first colonists arriving, unloading their ships and working together with robots to shape viable structures out of the red dust. A process that is not only efficient, but also resource saving, because everything is produced locally. Technical milestones play a crucial role here. Nuclear reactors ensure a stable energy supply, for example by upgrading the kilopower system to 1 megawatt, which reduces dependence on solar panels during dusty periods. In addition, initial terraforming tests with greenhouses enrich the thin atmosphere by deliberately releasing gases and enhancing the greenhouse effect. It's an ambitious step intended to gradually make the planet more habitable, even though critics warn that it could take centuries. And genetic adaptations for plants in the low gravity of Mars ensure that crops not only survive, but thrive. Here, advances in biotechnology play a key role, which we have to bring from Earth in order to overcome the challenges of gravity. By 2060, this will grow into a self-sustaining colony with 1 million inhabitants, including local industry that manufactures starships on site and an interplanetary trade that exchanges resources between the Moon, Mars, and Earth. Fuel from the Moon dramatically reduces costs, since it's easier to extract and transport in the low gravity. Of course, there are challenges that shouldn't be underestimated. Dust storms that may block solar panels, intense radiation with long-term health risks or psychological strain from isolation and confinement. But this is exactly where innovative solutions come into play, like virtual reality simulations for mental recovery, medical artificial intelligence that monitors health data in real time, and community designs that shape habitats to be artificial, getting stronger and stronger. The harvest is getting stronger and stronger. SpaceX plans to establish a true multiplanetary civilization by 2050, where humanity serves as a backup against Earth catastrophes. An optimistic outlook that shows how mistakes and setbacks only drive us to find smarter ways. The Mars Master Plan is ambitious but achievable. From the Artemis moon base in 2030 to SpaceX's Mars City in 2040, driven by Starship, In-Situ resource utilization, and global cooperation. What do you think? Are we ready to take the leap? Write it in the comments. If you like this Mars Master Plan, subscribe to Mars Chronicles and give it a thumbs up. A huge thank you goes out to all channel members and Patreon supporters. If you also want early access to our videos, you can find all the information about it below in the video description. I'm Sir One and this was Mars Chronicles. Thanks for listening. Pera spera ad astra.